This is the first video of scalar product, and I'm going to introduce the definition of scalar product. Scalar product is another name for scalar product is dot product. And what is scalar product? Scalar product is one of the product of vectors, right? Vectors, we have two types of product. One is the scalar product, one is the vector product. The scalar product is when the two vector you're doing the scalar product or the dot product, you are getting a scalar quantity, which there are no tilt here, right? This is a scalar quantity. Alright, what is scalar quantity? So as a physics student, you were quite familiar with this, which is a no direction, right? Directionless quantity, alright? It's just represent a magnitude or it's just a number. So as you say that A cross B is defined, this definition is defined to be the magnitude of A, magnitude of B, cos theta, right? Cosine theta. So this will be the very important definitions, as we can use this definition to get a lot of useful tips. Alright, means that, this means that, so from this definition, we can getting a lot of useful result, right? Useful result. So as I have to tell you that this is, we read as A vector A dot with vector B, right? Magnitude of A multiplied magnitude of B cosine theta. And what is the theta? Theta is the angle between the two vector A and B, right? Vector A and B. So this is the angle. Alright, so I said theta is the angle between vector A and vector B. So, and for your knowledge, vector A, the angle can take up to pi or 0, or we said 0 up to 180 degree. Alright, it's either acute angle or a obtuse angle. Alright, let's see some useful result. Let's see some useful result from this definition. Right? Let's look at the first one. Right? Let's look at the first one. So, as you know that A dot B is the same as the magnitude of A, magnitude of B, cosine theta. Right? As the angle between A and B. I also can write B dot A, as this is also a vector. It's a magnitude of B, magnitude of A, cos theta, right? It's angle between vector B and vector A. So this is a scalar quantity, right? Scalar quantity. So vector B, these two is the same, right? These two were giving you the same value, right? Just interchange this order. This is just a number, right? So, and we can, from this result, we can know that this is the same, right? Of course, that this will produce that A dot B is also same as B dot A. They are commutative. We said this to be commutative. Commutative means the order of multiplication is not important. So as they are the same, right? A dot B is the same as B dot A. So A dot, this is the first result, all right? A very important result. So it means that A dot B is the same as B dot A. All right, let's go for the second result. All right, okay, let's look at the second useful result. So if two vectors, two parallel vectors, right? Two parallel vectors. So either they are in the same direction, vector A and vector B is moving in the same direction. This is a parallel vector. Or we say that vector A and vector B, they are parallel, right? They are parallel means they have the same gradient. Or so when we say that these two have opposite direction, right? A and B have opposite direction. Okay, I repeat again. Vector A and vector B, vector A and vector A, these are actually a pair of parallel vectors, but this is same direction and this is different direction, right? Opposite direction or anti-direction. B is the anti-direction of A. So, and we can say that the angle between vector A and vector B. So if you join these two, they are actually angle is 0, right? The angle will be 0. And if you're joining these two, right? If you're joining these two, you will find out that the angle, right? Let's say this is vector A and this is your vector B. So the angle will be 180 degree, right? So from this vector to this vector will be 180 degrees. So we can say that the theta of this case will be 180 degrees. So how to using this definition, and we conclude important result here. So if they have the same direction, when they are parallel, okay, when these two are parallel, we can say that A dot B is the same as magnitude of A, magnitude of B. I just replace the cosine, the theta here, with 0 degree, right? Cos 0. As you know, the value of cos 0, right? Cos 0 degree is 1, right? So therefore, if A is parallel, right? Parallel to B, and in the same direction, right? And in the same direction. So we say that A dot B, then A dot B will be equals to magnitude of A, magnitude of B, the multiplication of magnitude of A and magnitude of B, right? So the other way will be if A is parallel to B, and in the opposite direction, parallel in the opposite direction, alright? Opposite direction. So the result will be A dot B is equal to magnitude of A, magnitude of B, cos, right? Cos 180 degree. Cos 180 degree, you know that cos 180 degree will giving you -1, right? So means that the result here will be the A dot B, the dot product will giving you negative, right? Negative of magnitude of A, magnitude of B. So this is a second important result here. So if both are parallel vectors, but if they have the same direction, it will be A dot B, magnitude of A, magnitude of B. So if they have anti-direction, opposite direction, we just add a negative, right? So this is the proof. So, and let's go for the third result. The third result is very famous and popular in almost every examination, right? So please focus on the third result. Alright, let's continue with this. How about if two perpendicular vector, means that vector A is perpendicular to vector B. The meaning of perpendicular is the vector A is perpendicular to vector B. So means that the angle between them will be a 90 degree, right? So then with this result, we know that A dot B is equals to magnitude of A, magnitude of B. The useful result here refer to using the definition, alright? You have to understand this. Cos 90 degree. As you know that cos 90 is actually 0, right? 0. So you multiply with this number, you are getting 0. So this is a very important result, simple and important. So if a vector is perpendicular to another vector, or vector A is perpendicular to vector B, then the important result will be A dot B will be equals to 0. So this is a very important result. Alright, very important result. So now I'm going to do some conclusion. Alright, so based on the angles, right? Based on the angles, okay, the conclusion here for this will be, let's say if vector A is parallel to vector B, right? And for example, if you know that cos theta, right? You know that cos theta, so add sugar to coffee, right? So we're not going to look at this quadrant because theta is between 0 and 180, right? So 90 to 180 degrees, right? And 0 to 90 degrees. So during this, the angles of the cos theta will be positive, right? Cos theta is positive. And in this quadrant, sin theta is positive, but cos theta is negative, right? Negative. So what's the meaning here is, let's say, let's say if the theta, right? If the theta is between 0 to 90 degree, alright? Okay, let's say between, right? Let's say between. So between 0 to 90 degree means that it's an acute angle, means that means that the angle is an acute angle. A dot B will giving you a positive value. Alright, A dot B, if you dot the two vectors, when you dot the two vector, you're getting a positive number. Let's say you're getting 3, 4, 5. Alright, based on here, means that if this is positive, right, means that cos theta is positive, right? Acute angle, because between 0 and 90 degree, cos theta is positive, right? So if this is positive, magnitude definitely is positive. This whole thing will become positive. So when you look at A dot B is positive, then we know that the two vector is actually very near to each other. It's actually acute angle. So but if the theta is more than 90, alright, an obtuse angle means that between 90 and 180 degree. For example, obtuse angle, right? Sudut cakar, right? So this is A, B. So then we know that A dot B, we're getting a negative number. Because why? Cos theta in this quadrant is negative. So when you're putting negative, if the theta is between 90 and 180, it will become negative. So multiply with this number, it will become negative. Means that A dot B will become a negative value. Alright? Or of course, except positive and negative. So if you find out to be A dot B to be 0, then what's the result? It will be perpendicular. Means that the angle will be 90 degree. Alright, the angle will be 90 degree. If A dot B is 0, the angle between the vector and B will be 90 degree. So, and combined with the useful result for the part 1 and the part 2, the useful result, everything, this will conclude about the result that can be used by using this definition, right? It's come from this definition. So hope you understand this video, and we go for the next video about the properties of scalar product.